So once we have a pretty good idea of what our data is, I'll show you how to actually import that shapefile of the attractions into Tilemill. So once I have the data saved out as a shapefile from QGIS, I can import it into Tilemill. And you remember last time we brought in our CSV information into Tilemill, we had all these extra points we didn't want. Now that we've edited that data set in QGIS, we can import that actual shapefile into Tilemill. So we go to Add Layer, Browse, and we find our file. And you remember here was our original CSV file, and here's the shapefile that we saved out from QGIS. So we select that. We'll give it a new name, and we'll go to Save and Style. And now if we turn off our CSV attractions file, we'll see that now we just have the shapefile we edited in QGIS. To provide a more accurate geography for us to reference these points, we can also bring in that same New York City base file that we used in QGIS. So here I have my New York City base shapefile. I can do Save and Style, and it'll come into this map. So at this point I can actually hide the countries layer because it's not detailed enough at the New York City scale. And I can move these layers around to avoid the overlaps. And here you can see that I have the same basic setup now as I did in QGIS, and I can do the same kind of visualizations using this Carto CSS markup language, which I'll show you an example of next. So here we're going to run into some trouble because in the categories of our data set, the numerical category that we want to use actually isn't considered a number, and we saw this before in CartoDB. And while CartoDB will let us convert the data field, Tilemill actually won't let us convert this data field to a number by default. We actually have to do it in QGIS. So when we brought in this CSV, convert into a shapefile, this numerical data set actually stayed as strings because by default CSVs come in as strings. In order to fix that, we basically want to create a new data field that copies over all this information, but that data field will format as a number field. So to do that, we'll start editing this spreadsheet, and these spreadsheets can be edited the same way as you can edit the data in the map viewer. Basically, once you click this edit button, you can edit any of these fields. And then what we can do is, by using this calculator, create a new field with values depending on the values of any of the other fields. So in this case, we're going to create a new field called reviews, and here we specify the field type, it's a whole number, and then we can just tell it to adopt whatever the value of number of this field. Double click so it's in here, and click OK. So here it's created a new field called reviews. The number is the same as it was here, but you can see it's right justified, which tells you that it's actually a number or an integer field. And now we can just delete this number of field and then save and get out of edit mode. Now if we go in here, we see that we have the same category field, name, and then now reviews is a number field. So at this point we can save as into a new shapefile, just call it attractions4, export that, and then re-import that file into Tilemill. So it's a bit of a pain, but it's just something to remember, that when you import a CSV file, everything will actually come in as text data, and you need to convert any field that you want to use numerically into numerical data in QGIS before you export the shapefile. So here's the new data. It looks exactly the same as before, but now this field is actual numerical data instead of text data. It's called reviews. So now I have this data. Again, it's by default width 2. Now I can bring in this conditional logic and say if the value in the reviews field is bigger than 50, then make the marker width 3. And now, since that's numerical data, it's going to be able to make that comparison. Okay, and now I can go through and add more of these conditions and say maybe if it's bigger than 100, make that 10. So now you can see how we can actually start to use Tilemill to bring in layers of different kinds. We can bring in point data, we can bring in shapefiles, and we can use this Carto CSS language to style that data and visually represent it the way we want. So it's a little bit more difficult than using CartoDB because you actually have to use this markup language. But if you take the time and look through this documentation, you should be able to find how to do what you want to do. And there's also tutorials online that go through different ways to visualize your data. So that takes care of most of the data types that you can load into Tilemill. The one thing we'll cover next is how to bring in raster data, and we'll do that by doing some heat map analysis in Quantum GIS and then bringing those results into Tilemill. So the first thing we have to do before we start making our heat map is actually to change the coordinate system of our point file from a geographic coordinate system to a projected coordinate system. And the reason we have to do that is because heat maps work with distances, and if you use a geographic system like we are now, you can see down here the readout is in latitude longitude, which is fine for displaying the data, but it won't give us an accurate unit of measuring. You can see that by, say, if you have a certain level of zoom in your view, you have your scale here. As you move to the side, the scale actually changes. That's because these projection systems don't maintain consistent units of measure. So in order to switch our projection system, we actually have to save as our point data. So we right click on the point data and go to save as, and here we can create a new file name. So I'll just call this projected, and then here I'll select a new CRS, and I'll select one that's actually a projected system. So here we're using geographic coordinate systems before, now we want a projected one. And the one we're going to use is this WGS World Mercator. It's pretty similar to WGS 84. It's a pretty standard projection system to use, and Mercator is just a type of projected system. It's one of the most basic ones. So if you don't have it here, you just type in WGS 84, and then under projected coordinate systems you'll get a lot of different WGS 84s, and you just want to pick the one that says World Mercator. Click OK. So now we have both of these point files, and you can see that we can zoom to each one, but they're not actually in the same space because they're actually in different projection coordinate systems. So the one that we projected to Mercator is the one we're going to use for the heat map. We can display both of these in QGIS because it supports something that's called on-the-fly transformation. So what this will do if you enable it is it will actually dynamically project data into whatever coordinate frame you specify. So if we pick here that our project will use World Mercator, it'll project dynamically this WGS 84 layer onto that projection. So this is useful if you're using data that's using different projection systems to get them all in the same space. For our purposes, we can hide this one, and we'll actually work with this point file to do our heat map.